Okay, so apparently the first time I recorded this video, the audio was turned off. So let's try this again. Finding the x and the y-intercept. You can use the standard form of an equation to find the x and the y-intercept, to calculate the x and the y-intercept. Let's go back over what standard form is first. In standard form, a, b, and c are integers. Now, whenever you first learned integers, or if you're thinking about integers in 7th grade, you should be thinking the real number system, where you have natural numbers, whole numbers, integers, rational and irrational. Now, the good thing about all of that is if you didn't understand it, didn't learn it, it's not covered in algebra. But integers and other, if you didn't understand it back then, integers are essentially just any type of whole number, okay? Just any type of whole number. Meaning positive number, negative number, and also including the number 0, okay, whose greatest common factor is 1. Now, a, talking about coefficient of a, or the number in front of x, must be positive. And a and b cannot both be the number 0. A and B can't both be 0. Why can't they both be 0? Well, if you would multiply 0 by x and 0 times y, 0 times anything is 0. So essentially what would happen is you're canceling out both your variables, and you can't do that. Now, to actually calculate the x and the y-intercept, let's talk about those two features of the graph. The y-intercept is the point where the graph crosses the y-axis. Okay? And in this graph right here, the y-intercept is the number 6. Okay? Words that we use for the y-intercept, things that we've gone over, it is the starting point. It is the starting point. And x-intercept, also called the 0. Okay, now just like we have other words that are used to represent the y-intercept, a word in a word problem used to represent the x-intercept is 0. And it's not talking about the number 0, it's just talking about the x-intercept. Why they picked the number, the word version of the number 0, I have no idea. Anyway, and it is the point where the graph crosses the x-axis. Okay, so record the ordered pair of the x and the y-intercepts below. Ordered pair meaning the full x and y point. And we will be doing this for a reason. For the x-intercept, the line's crossing the x-axis at 8, 0. The y-intercept is 0, 6. Okay, why is it important to know how to write those? Because in an x-intercept, the y value will always be 0. And in a y-intercept, the x value is 0. And that will help us calculate the x and the y-intercept. So when we're actually finding the x and the y-intercept, we're calculating, solving for it, what you're going to do is you're going to plug 0 in for the number, or for the letter y, or for the variable y. Okay, so you're going to substitute. When you substitute, you use parentheses, and you finish solving for x. So 2 times 0 is 0. That cancels out, and you're left with x equals 6. Letting you know that the x-intercept for this line is 6, 0. To solve for the y-intercept, you're going to do the opposite. You're going to plug 0 in for x this time. So using the same equation, x plus 2y equals 6, you're going to replace the x with the 0, but 0 is 0. That cancels out, and you're just left with 2y equals 6. So the only step is 2 divided by 2. 6 divided by 2 is 3, making the y-intercept 0, 3. And once you have at least 2 points on the line, on the graph, you can create your line. Okay. Let's try the next one. So with this one, same thing. You're going to solve for the x-intercept by first finding the by first plugging in 0 for y. So we're going to take 4x plus 7 times 0 equals 28. 7 times 0 is 0. You're left with 4x equals 28. So we divide by 4. You get x equals 7. Making my x-intercept 7, 0. Plot your point. Okay. For the y-intercept, you're going to do the opposite. You're going to plug a 0 in for the x. So 4 times 0 plus 7y equals 28. 4 times 0 is 0. That cancels out. Divide by 7. And you get y is equal to 4. 0, 4. You have 2 points on the line, so now you can connect and you'll have your graphed line. Okay, at this point, there was a student that noticed this. Whenever we solve for the x-intercept, the answer ended up being the coefficient of y. And when we solve for the y-intercept, the answer ended up being the coefficient of x. Just letting you know right now, that is something that does not always work out. For this one, it's just a coincidence. If you look at the first example, we solved for the y-intercept, and that answer was not the coefficient of x. So just letting you know, in case you do notice that. Let's see, and I was going to point something else out, but I forgot. I'll go over when I remember. So let's continue, and we're going to solve first for the, another student asked, well, how do you know which one you're solving for if you're just plugging zeros into random spots? Well, think of what you end up with. X equals here, x equals here. When you're done solving the equation and you end up with x equals, you have solved for the x-intercept. Here, when you're done solving the equation, you ended up with y equals, you have solved for the y-intercept. So just little things that you can use. Okay, this is more of the same practice, but this time you don't have to graph. So we're going to practice one more time. First thing we're going to do is solve for the x-intercept, which, I'll just write it over here to the side. I'm going to solve for the x-intercept. So 4x plus 6 times 0 equals 12. 6 times 0 is 0. You're left with 4x. Divide by 4. And you get x equals 3. So your x-intercept is 3, 0. Solving for the y-intercept, you plug in a 0 where the x is. 4 times 0 is 0. You're left with 6y equals 12 divided by 6. And you get y is equal to 2. Okay. You would essentially end up doing the same thing on number 4. Just 1 or 2 step equations. So I'm going to move on. Okay. Number 5, it says this isn't a word problem. This is how you would most likely see it on the STAR test. It says, part A, where will the 0 of the graph be? Well, they're asking for the 0, so they're asking for the x-intercept. Asking for the x-intercept, that means you're going to plug in a 0 where the y is. So x plus 3 times 0 equals 24. 3 times 0 is 0. Divided by 8. You get x equals 3. 3, 0 if they ask you for a full ordered pair. Now, to know whether a point will lie on the graph. This has nothing to do with solving for the x and the y-intercept. You're just trying to figure out if this point will end up being on the graph of 8x plus 3y equals 24. When you're presented with the full point that is not an x or a y-intercept, you're not solving for the x or the y-intercept. You're going to plug in both numbers. 3 is an x value, negative 5 is a y value. My original equation is 8x plus 3y, 24. So I'm going to replace x with the number 3, and I'm going to replace y with the negative 5. 8 times 3 plus 3 times negative 5 equals 24. Now I can put all this, or this whole side of the equation, into the calculator. And once I put that into the calculator with parentheses and everything, you should get the number 9. Oops. Bring down the 24. Then you ask yourself, is 9 equal to 24? No, they're not equal, making it a false statement. Because it's false, we know that this point is not on the line. It will not lie on the graph. Okay. The next one, Hans went to the fair. Part A is asking how much did each ride cost. The word each is a word that represents the slope, but you cannot tell me what the slope of the line is when your equation is still in standard form. So the only way to answer that would be to solve for y. You solve for y by first moving 5x over, subtracting it. A place where a lot of students make mistakes is they forget to bring down that negative. So that is still negative 2y. Don't forget the negatives on the 30 and the 5. Last step is to divide. You do not change the sign when you divide. So you get y is equal to, when you type this fraction into the calculator, simplify. Make sure you're simplifying each and every fraction. It'll change it to a positive 5/2x plus 15. Now out of both numbers, the slope is 5/2. But we're talking about the cost, and 5/2 does not make sense in this situation, forcing you to convert it to a decimal. 5/2 is 2.5 or $2.50. Part B is asking for the entrance fee. Entrance fee would be the beginning cost. It's what you're going to pay starting off, correct? So since it is a starting fee, you know that they're asking for the y-intercept, and the y-intercept is 15. Last one. Which of the following represents the equation of the graph line? Well, there's a couple of different ways that you can answer this question. One way would be to take each one of these equations and solve them for y, but I believe that that is the longest way. The shorter way is going to be to take this point, or take one of the points and plug it in. Plug in the x and the y value. So you're going to plug in negative 6 for x and 0 for y, just as we did here in this problem. So what we're going to do here is replace. So we get 3 times negative 6 plus 2 times 0 equals negative 12. Well, 2 times 0 is 0. 3 times negative 6 is negative 18. And negative 18 is not equal to negative 12. So this point is, or this equation is not that line that is graphed on the side. Next one, 2 times negative 6 plus 3 times 0 equals negative 12. 2 times negative 6 is negative 12. Negative 12 is equal to negative 12, or sorry, it is equal to negative 12, making it a true statement. So this is the equation of that line. Okay. You can always check your work as well. If I solve this, you bring down the 3y and divide by 3. You get y equals negative 2/3 x, and negative 12 divided by 3 is negative 4. Well, it tells you that the y-intercept is negative 4, which is correct, and that the slope is negative 2/3. So let's find the slope of this line. My rise, 1, 2, 3, 4, and my run is backwards, and you run negative 6. So 4 over negative 6 also simplifies to negative 2/3, which checks out as well. So yes, this does match that graph line.